Let's talk about current noise of FET input amplifiers. That could be CMOS amplifiers, that could be JFET input amplifiers. So a reminder on current noise, so we model current noise as a little current source at each of our inputs. That current flows through into whatever is connected. So in our case, we have this mega ohm output impedance sensor. So that current is going to flow into that mega ohm output impedance and is going to generate some little voltage noise here at the input. Same thing if we had feedback resistors. That current is going to flow through this feedback resistor and is going to generate a voltage noise here as that current interacts through that resistor there. So let's look at our graph. So this purple line here on our graph says amp I plus. So that stands for the current noise at the positive input. And we can see that it ramps up here. And that may be something new or unusual to you. So until recently, we did not put current noise graphs for FET input parts into our data sheet. So we would typically put a number for low frequency current noise, but the general assumption was that, hey, FET input current noise is so low, we don't really need to mess with it. Well, it turns out that there is this ramp at higher frequencies, and occasionally it comes into play. So a lot of times you'll have enough capacitance at your input and it won't matter, or you're rolling it off with filtering and it won't matter. So a lot of times it still doesn't matter, and remember, you're starting from a very low base. But there are occasionally times where it does matter, and so we have started putting it in our data sheets. So here is an example, this new part, this 884510, and we are using this blue line in Signal Chain Designer. So if I go look here, it looks like at 10 hertz I have about 3 femtoamps, maybe a little over, let's see, 1, 2, yeah, a little over 3. No, a little over 4 femtoamps there. And if I go here and look at 10 hertz, I'm getting 4.2 nanovolts per hertz. So I'm getting 4.2 nanovolts per hertz because you take that 4.2 femtoamps, multiply it times a mega ohm, and that's how you get your 4.2 nanovolts per hertz. We're doing referred to input, so we're good there. If we were referred to output, you'd see that it would say 42. So do watch for this referred to input, referred to output thing. Let's do just one more check. So I'm going to go to 10 kilohertz. Looks like 10 kilohertz is about 300 femtoamps. And so if I go to 10 here, we're at about 303 nanovolts per hertz. So that all checks out. That looks great. One thing to know is we've got this really nice article by Kong Wen called Current Noise in FET Input Amplifiers. And it goes through this behavior, and it's got this nice little chart here at the bottom that compares a few different FET input amplifiers. So a nice little write-up on this behavior. I think as far as we know, Signal Chain Designer is the first kind of modeling software to actually model this behavior. So if you were to export to LT-Spice or compare to your hand calculations, you may get a different number. And so just watch out, because we are attempting to be more accurate for you all so that you're getting as close as we can get to what you'll get on the bench. One other interesting thing is, I think it shows better if we're at a gain of 1. All right, so here is this green line which says amp I minus, and we have, which is the current noise here. And you might say, well, what in the world, why do we have any kind of line? There's no resistances attached here. And what's happening is that current noise is flowing through the output impedance of the part. So here's our output impedance, and so it's generating enough of a thing to show up on the plot. It's not going to matter in terms of your measurements, but it is there. So if you were wondering why it's there, that's why, because that current noise is acting against this output impedance of this amplifier. Okay, so that's the story on current noise of FET amplifiers. This effect does not affect BJT amplifiers, only CMOS and JFET input amplifiers.